Hi guys, and welcome to this video today on area of sectors. Really good to see you. My name's Darren and it is a pleasure that you have joined me for this video. Area of sectors. Building off from my previous video where we found areas of circles, and then yes, we may have had some composite shapes, so we may have found a quarter of a circle or a hemisphere. Well, what if they're not those easy quarter, half circle, three-quarter circles? Well, basically, long story short, that's what this video is for. Any section of a circle that you cut out is called a sector. Doesn't matter if it's 10 degrees, 90 degrees, 180 degrees, it is a sector. And we can find the area of that sector using information probably you already have. And I did allude to it in my previous video. If you haven't watched it, you can do so. Where is it? Well, it's on YouTube at MaffsGuru.com. Now, if you haven't already done so, can you subscribe over there by clicking the doohickey? There's about 12 people watching these videos. And so if you could be the 13th, I'd be deeply grateful. In fact, it just lets me know that you're watching. Never going to be rich, never going to be famous. Above me is going to be my website link, MaffsGuru.com, where you can find all these videos. You can search for videos. They're organized by textbook, by chapter, and they have downloadable notes. All right, so head over there. Best thing I can do for you today, except doing your homework for you. And no, I'm not doing that. Okay, so areas of a sector. As I said in a previous video, I have recapped the fact that we can find the area of a whole circle using that formula there, pi r squared. Weirdly, I think if I ask my mum for what the area of a circle is, my mum's heading towards 70. The chances are she'll be able to tell me. I don't know why, but that's the one formula that most people always seem to remember from school. Weird, huh? Pi r squared. And this picture here is just a different visual representation of how you can use it. All right, and how do we find it? Well, all we needed to know for the area is write our formula, which is pi times radius squared. And we remember that radius squared was nothing more than the radius multiplied by itself, radius times radius, which is why sometimes we see the formula as pi times r times r. Now, obviously, we got to the point where we said, oh, there wasn't a whole circle here. So how do I find the area of this? Well, you find the area of the whole circle using pi times radius. And in this situation, that would be pi times 2.5 times 2.5. And then once we've got the value of that, we would then find half of the circle by halving that value, all right? So that's the way you do half a circle and a quarter circle. But I know this seems a bit weird, but what is a fraction? Well, if we look at a fraction, it's nothing more than some sort of section of it. So I love pizza. So here is a pizza, and if I split it up into, let's say, 6 pieces, and there are my 6 pieces of pizza, if I take that one piece out, how much of the pizza have I got? Well, I've got 1 piece out of 6, or 1/6 of a pizza. Now, why did we know it was 6? Well, because we've cut our pizza into 1, 2, 3, 4, 5, 6 pieces, and I've subtracted, or I've taken 1 piece. What about if I was to take 4 of those pieces? 1, 2, 3, and 4. Well, fractions tell me I would have taken 4 out of those 6 pieces. How does this relate to a circle? Well, how many degrees are there in a circle? 360 degrees, right? So there are 360 degrees. So if I have some sort of section of a circle, which is nothing more than a pizza, we just got to imagine it's cut out into 360 pieces. And so if that was 40 degrees, then the fraction of the circle I've got would be 40 out of 360. Now, why is this fraction important to me? Well, remember, previously when I had half a circle, I did half of the area. When I had a quarter of a circle, I did a quarter of the area of a whole circle. And here is the area of a whole circle. So what do you think I would do to find the area of this circle, or this sector here? And that's called a sector because it's basically a slice of the circle. I would find 40 divided by 360 and times it by my whole area, because it's this fraction of my circle, and that's the area of a whole circle. OMG, this is freaking awesome. So how are they going to do this? They're going to try and trick you. Here we go. How many degrees are in that? It's a right angle. So that would give me 90 out of 360, which again, using my calculator, that's what it's there for. So let's edit and clear all this down. If I do a fraction, not a squared and a fraction, don't know what's going on with my keyboard today again. So if I do 90 and I do divided by 360, make sure my calculator's in standard and hit execute, it's a quarter. We could see that. Yeah? Now, obviously, if you're sitting there shaking your head going, why did I use a calculator? There are lots of people watching these videos, all right? Lots of people, very different abilities. Hopefully, I'm here to help as many of you as I can. What about this one? Well, I've got 60 degrees out of 360. So imagine I've got 60 slices of that 360 degree pizza. Again, put it into my calculator. 60, I hit 560 divided by 360 gives me 1/6 of my pizza, and likewise 120 degrees over 360 degrees, I'm going to tell you that that works out to be 1/3. So how does that help me? Well, now I've got 1/4 of my whole area, I've got 1/6 of my whole area, and I have 1/3 of my whole area. Marvelous. Now, you know, at the end of the day, we're mathematicians and we quite like giving you strange formulas, but there we go. Area of the sector is equal to the angle of the sector divided by 360 times pi r squared. That's nothing more than what I've done here. So in this situation here, the area of the sector, the angle of the sector is 60 degrees, divided by 360 degrees, which we've got there, and then times it by the area of a whole circle, because we're not finding the area of a whole circle. All right, find the area of these sectors, correct to 2 decimal places, always important. Find out my calculator, because it sounds like I'm going to need it. And so area in this situation is, well, I've got 120 degrees out of the 360 degrees, which I'm going to times by pi r squared. Well, I know that that's going to be 120 divided by 360 times pi. My radius is 2 squared, and I can just put the rest of that in my calculator. All right, there we go. So 120 divided by 360. And then we're going to multiply that by pi and multiply that by 2 squared, which gives me the fabulous value of 4 pi on 3. Huh? Now, if your question asks for an exact answer, that is exactly what it's looking for, no pun intended. I'm going to put that back in decimal mode, hit enter, and out comes the area of that as 4.19 centimeters squared. There is nothing more complicated than this, even when you look at that, yes? What is it? It's trying to trick you. So, what do you notice about the angle? Where is it? It's outside my circle, but sectors, you have to know the area inside. So how many degrees are there in a triangle, in a circle? 360 minus the 70 gives me that that is going to be 290 degrees inside. And actually, that's the angle I'm going to use. So area is equal to 290. That's how big my sector is, divided by 360 times pi times my radius, which is 5, and squared. The rest of it now just goes into my calculator. So deleting that again because I hit the button too many times. So we're going to do 290 divided by 360. I'm going to times that by pi. I'm going to multiply that by 5 squared, which happens to know is 25. And there we go, 63.27 meters squared. Nothing more than there, right? There's nothing more complicated than this. And again, as we are wont to do, examples of composite shapes. What's a composite shape? Well, that's where either shapes are put together or they're subtracted from each other. Oh yes. So can you see the composite shape here? Well, I can. So first things first, we have a rectangle, and then we seem to have a quarter of a circle, but they've tried to be sneaky here, right? So whereas I know that this rectangle is 10 by 20, can you find the radius of this circle? Yep. Hopefully you realize the radius, that 10 millimeters, and that 10 millimeters is actually the radius of that circle as well. Right, okay, so the area of the rectangle is given by 10 times 20, which is 200 millimeters squared. The area of my shape there, well, I can go straight to the fact that I've got 90 degrees because of my right angle, out of 360 times pi times radius, which is 10 squared. Now I know that 90 on 360 is a quarter, so I can go straight to that with 1/4 multiplied by pi multiplied by 10 squared, which I also know is 100, gives me 78.5398 ... millimeters squared. Why am I not rounding this yet? Because I'm not at my final answer yet. So the area of my composite shape, which looks roughly like that, is 200 minus 78.5398 ... equals, so was it 200 minus my previous answer is going to give me 121, and now I'm going to round it, 46 millimeters squared. Job done. What about this one here? Pretty much the same, I think. Yeah, they've just tried to trick me. How? Well, again, I'm going to find the area of the rectangle, I'm going to find the area of the hemisphere, and then I'm going to take them away. Right, area of the rectangle is 20 times 10 again, which is 200 millimeters squared. That was nice and easy. Thank you very much. That's 2 marks already, or maybe 1 mark. Area of the hemisphere, well, I've got 180 degrees out of 360 degrees, times by pi, times by my radius. Do you see the trick? It's not a radius, that's a diameter. So multiply that by 8 squared gives me, well, I know that that's a half, so I'm going to do 0.5 multiplied by pi multiplied by 8 squared, which is 64, gives me 100.53 millimeters squared. And so therefore the area I'm looking for is going to be 200 minus 100.53 and lets my calculator do all the hard work. 200 minus my previous answer. Hit enter, gives me 99.47 millimeters squared. And there we go, ladies and gentlemen, we are done with areas of sectors. Thank you so much for watching. Hopefully it was useful. We've gone through the formula, we've done some examples, and you are now a guru too. It's been good to see you. Hopefully I'll see you on other videos. If you haven't already, can you subscribe? Send the word out to your classmates and your friends, TikTok or wherever, and just let them know my channel's here. I would be deeply, deeply grateful. If not, I'll look forward to seeing you next time. All right, you stay safe. Bye-bye.